Hi everyone. In today's class, we'll be treating heat transfer, and we have three methods of actually transferring heat. We have the radiation, we have the convection, and then we have the conduction. But then, before going into each of these different methods, let's talk about what heat is. So we'll have an idea of what we should actually take note of when we are dealing with the different methods of transferring heat. There's a certain characteristics that is peculiar to heat, and it is that when the heat is very high, it's related to the temperature. So the higher the temperature, the higher the heat that the body will emit. And we all know from kinetic theory of gases that temperature is a function of the kinetic energy of the molecules that make up that particular substance. So that means you can translate that to it being a function of the kinetic energy of the molecule itself. And it is a form of energy. Take note, it is a form of energy, and specifically is a form of infrared energy. So in case you are asked that, it is a form of energy, which of these can be used to represent it, you have different electromagnetic force. Don't assume that because it is energy, it's not radiation and that kind of thing. It's actually an infrared radiation that actually make you sense that heat transfer, the heat itself. And the stuff about it is the fact that it is always being transferred. It's always in motion. So if you have two bodies now, you have a body with a particular temperature, the stuff is very hot, it will definitely emit heat. So far that the surrounding of that particular substance has a lower temperature than itself, it will transfer it to that surrounding. And also, it's very important to take note that heat transfer is actually due to the difference in temperature between the body and its surrounding. So in order for there to be heat transfer, the temperature of the body must be different from the temperature of the surrounding. So it can either now be that it is being transferred from the body or it's being absorbed by the body. So it depends. The only place where the temperature now determines the temperature difference basically determines the direction. It also determines whether it is transferred. So a body with a lower heat energy, a body with a lower temperature will absorb it from its surrounding, while a body with a higher temperature will emit heat to its surrounding. I hope you get that. So the atoms are in different types of motion at any time. The motion of molecules and atoms is responsible for heat or thermal energy. I already said that. And every matter has this thermal energy. The more the motion of the molecules, which is the kinetic energy, the more with the heat energy that particular substance, that particular molecule actually possess. Now, however, talking about heat transfer, it is nothing but the process of transfer of heat from a higher temperature body to a lower temperature body. So now these are some of the things I'll be talking about, define what heat transfer is and how heat transfer actually comes to play. I think I already gave a short idea of what heat transfer entails, and then we'll talk about the different methods of actually transferring it. Now, according to thermodynamic system, heat transfer is defined as the movement of heat across the border of the system due to difference in temperature between the system and its surrounding. So as I said before, that heat transfer is due to the different temperature between two bodies. Now, the body that you are referencing, like the body that you are concerned about, is the system, while the other body surrounding it that you are not concerned about is the surrounding. So if there is a temperature difference between that body that you are concerned about and its environment, then there will be heat transferred between the two entities, both the system and the surrounding. Now, how is it transferred? I already said before, we have three methods of actually transferring it. You have the conduction, you have convection, and then you have radiation. And the way I always tend to view heat transfer is more like a way for you to transfer temperature from a body to another. Like, because if it is transferred from a body to the other body will increase. The temperature of the other body will increase, and the temperature of the body that transferred it to the other body, Let me so as not to confuse you guys. Let's say you have body A, you have body B. Now if body A transfer it to body B, now the temperature of body B will increase while temperature of body A will reduce. So it's more like a way of actually transferring temperatures if you actually look at it from a different angle. So now let's start with conduction. What is conduction? Now conduction is the process of transmission of heat from one particle of the medium to another, with the particle being in direct contact with each other. So that also actually, in which state of matter? We already did state of matter. In which state of matter are the particles in direct contact with one another? Is what is in solid. So that means conduction is a form of transfer of heat in what? In solid particles. Conduction is a form of transmission of heat in solid particles. This diagram basically just explains, it gives you an idea of what conduction is. Conduction is at the handle, like the handle of the port. So basically, usually between conduction is usually transfer of heat within a solid particle. Now, an area of higher kinetic energy transfers thermal energy towards the lower kinetic energy area. So it does not necessarily have to be the way it's represented in this diagram where you actually touch it. Now, if you heat a certain part, if you apply it to a certain part of a solid, you notice that over time the temperature or the heat will move to the other part that you're not even like applying it to. Let's use cooking for example. Now you place your pot on the fire, on the stove or the electric cooker. The point of application of the heat is at the bottom of the pot. But then you notice that over time, when you touch the handle or you touch any other part of the pot, you notice that particular part actually has a higher temperature. It's very hot. Why? Because its energy was transferred from the base of the pot to that particular region, and the way that the heat energy is transferred to that point is by vibration of, because when you apply it to a solid, the particles vibrate, and when they vibrate at a very high energy such that they collide with particles close to them. That one to gain kinetic energy, it collides with the one close to it till they spread out the kinetic energy to every part of that solid. So that's really what conduction actually entails. And there is a formula for calculating rate of conduction of heat energy. Take note that you have rate of conduction for convection too, but then it's a different formula. But then for solids, when you are dealing with conduction, the formula for calculating the rate of kinetic energy is, and don't forget that rate of energy is what? Ignoring the rate of heat transfer, its energy transfer. Now don't forget that the rate of heat transfer itself is what? Is power. Energy per time is what? Is power. So it can be in terms, they might say that what's the power that is required to heat a particular substance. So they are still talking about the rate of heat energy transferred. So the rate of heat energy transferred, the formula calculating rate of heat energy transferred is the thermal conductivity of the body times the area of over the transfer, like the base of the pot that I used as an example the other time, and then multiplied by the difference in the temperature between the two systems, the heat where you are actually applying the heat, the hot body, the temperature of that hot body and the temperature of the cold body. You look for a difference in the two temperature, and then you divide it by the distance between the two bodies, like the thickness of the body. You divide it by the thickness of the body. So that, now it depends. You use thickness when it is, you are just trying to calculate the rate of heat transferred within a body. But if you are trying to talk about the rate of heat transferred across like a distance, like from one body to another body, then you use distance between the two bodies. But then in this case that you are just trying to calculate the rate of heat conduction by a particular body, you use the thickness of that particular body. So examples of conduction, you have ironing of clothes. Yes, that's basically what that is a very good example of conduction. Example of cases of conduction. Now, when you place your hand on a ice cube, it is being transferred from your body to the ice cube. You know that when you hold the ice cube, it tends to like melt. That's because of your the heat that is escaping from your body towards the ice cube. Now let's now talk about convection. Now, what is convection? Convection is the movement of fluid molecules from higher temperature region to a lower temperature region. Now take note that for conduction is what? Solid particles. While for convection is what? Fluids. Now don't forget, I said it when I was talking about state of matter. Fluids, basically, we have two. Under fluids, we have two state of matter under fluids. You have the liquid and then you have the gas. So fluid is not just liquid, it is both liquid and gas. So convection is like the movement of both liquid and gas molecules from region of higher temperature to region of lower temperature. And that's example of that is where when you open, after you've boiled the water you are cooking, and then you open the what's called the cover, you notice that there'll be like vapor coming out, and that particular vapor will be what? Very, very hot. So it is being transferred from whatever it is you are cooking to whatever surface that the vapor actually eats when they escape from the pot, when you open the pot. So I said before that there is a particular equation for calculating the convection. Like for conduction, we have formula for calculating the rate of convection. Right? For convection, we also have for convection. And for convection, it is the rate of heat transferred. Heat transferred is equal to the coefficient of convection heat transferred times the area, and then times the temperature difference between the two bodies. Now they won't ask you this in your UTM, but then it's better to be safe than sorry. Now examples of convections, we have example of convection, we have boiling of water, when the water molecule actually escapes. And then we have when you are warming water in an equator height, the poles. And then you have the blood circulation in your body too. That's also an example of transfer of heat energy by convection. Now then, radiation now. Now what is it? What is radiation? What is it? What is it radiation? Now, thermal radiation is referred to as radiant energy. As I said before, that the heat energy is a form of like radiation, which is the infrared. So it's possible for you to actually, you notice that when a particular surface is very hot, you don't necessarily have to be in contact with it for you to actually feel the heat. Now that sensation of it that you are feeling is due to radiation, like the infrared coming from that surface, that particular surface, to yourself. And then they use this in now radiation heat transfer is measured by a device known as thermocouple. Just take note of that. It is measured using a device called thermocouple. Now, as I said, that for convection, for conduction, we have an equation for calculating the rate of heat transfer. The same way we have for radiation as well too. And that's radiation. They won't ask you this actually. This is actually 100 level stuff. They won't ask you, but then just to satisfy your curiosity. So those are the methods of actually transferring it, both across a solid, liquid, and then through vacuum. And the unit for heat transferred is joules, because heat transfer itself, heat itself is what is energy. So see you guys in my next class.